So only one. Write a function only one, right? That accepts 3 arguments of any type. Okay, so we have a function, right? We have a function called only one, and it takes 3 arguments. So they're going to give us 3 things. And only one should return true only if exactly one of the 3 arguments are truthy. Okay? Otherwise, it should return false. So basically, we're going to be given 3 things. And we want to make sure that only one of them is true, right? If just one of them is true, or truthy, then we're going to return true and say that only one of this is true. If all of them are truthy, right, we're going to return false. Because only one can be true, right, according to what they're asking. Return true only if exactly one of the 3 arguments. It's not like at least one. It's exactly one. If there's 2 things that are truthy, that doesn't count, right? It has to be just one. Do not use the equality operators in your solution. So in this case, right, we have false, false, true. How many truthy things are in here? 1, right? So that passes. And here, how many do we have? How many truthies? Yeah, we have 2, right? 0 is falsy, 1 and 2 are both truthy. And so we return false because there's more than one thing that's truthy. Does that make sense? It's a little weird. So let's do this. Bring over the examples. So this question is like it's definitely weird. I will concede that. So let's define this function. We'll say I'll use arrow functions this time. So const only one equals parentheses fat arrow curly braces, right? And then in here we put in the list of arguments. How many arguments are we expecting here? 3. So you can call this like I'll just do like ABC. You can call it whatever you want. But these are going to be the arguments, right? So in here, right, we want to make sure that just one of them is truthy. So you're not going to love the answer. But the way to do this is kind of just like manually check and see if just one of them is truthy, okay? So what does that mean? If A is truthy, what has to be the case about B and C? They have to be falsy, right? So if A is truthy, right? If A is truthy, right? Then B and C also have to both be falsy, right? So you can say, okay, if A is truthy, right? And if B and C are falsy. So if B is falsy and C is also falsy, right? So if B is falsy and C is also falsy, return true. I'm going to solve this problem in a variety of ways. This is just the first way. So let's walk through this. If A is truthy, if A is true, right, then we get to go in here. Okay? Then we get to go in here. Now, just because we go into this if statement doesn't mean like we immediately return true, right? If A is true, we get to go in here, but we also have the secondary check, right? So this is like, imagine this is the first level. This is level 2. Let's check if we can pass this level, right? How do we get through this if statement? Well, B has to be false, falsy, right? Because what is the opposite of something that's falsy? It's true, right? Let's say B is literally false. What is not false? True. Okay, great. We have true here, and well, let's say C is false. Okay, what's the opposite of false? True. Okay, so true and true. That means we get to go in here and return true. Does that make sense?
No, because it's true that it's false.
It's true that it's false.
Okay.
It's true that B is false and C is false.
Okay.
Right?
Yeah.
Like, if B is false but C is true, what happens? This is true, and let's say C is also true. What's the opposite of true? It's false. So what's true and false? What's the result of that? That's false. So we don't get to go in here. And so, yeah. So this is, I mean, this is the English version of it, right? If A is truthy and if B and C are falsy, then return true. Because why? That means exactly one thing is true, and that's A. And so we kind of do the same thing for the other one. So if B is truthy, and if A and C are falsy, that means only B is true and A and C are false. Right? This is the same thing as this, except we're saying B is the only thing that's true and A and C are both false. Here we're saying A is the only thing that's true and B and C are both false. Right? And then finally, if C is true, then A and B both have to be false, right? Because if C is true, since we can only have one thing that's true, everything else has to be false, right? Return true. And then finally, right, if we get through all of these if statements and we haven't returned true yet, that means we're in a situation where, like, since we've exhausted all the possibilities where only one of them can be true, right, we can just return false down here. So, okay, so the question was, is exactly one thing in this set of three things truthy? And so to answer that question, you basically set up these three literal scenarios, right? Where if I want to make sure that just one thing is truthy, then I'm just going to play through all the scenarios. Where if the first thing is truthy, the other two have to be false. If the middle thing is truthy, the other ones have to be false. And if the last thing is truthy, the first two things have to be false. There's no other situation where this passes, right? And so if one of these cases isn't satisfied, then we reach all the way down here and we just return false. This is one way to solve this. Okay. So let's see if this works. True. False. Okay, so why did this one work? Why did this one work? Because we have false, false, true, right? Okay. We have false, false, true. Okay. If false. Does that make sense? No, we don't do anything. Right? So we skip this. If B, what's B? B is false. Do we go in here? No. B is false. Okay, so we skip. We go here. We have false, false, true. So C is true. Great. So let's go in here. So it's like we're doing if true, right? And then if not A and not B. So what's the opposite of what A is? True. And what's the opposite of B? It's true. So true and true. So we go in here and we return true. Right? So we've hit the case where exactly one of them is true, and because the last thing is true, false, false, true. Right? Okay. What about this one? Right? We have 0, 1, 2. Okay? 0, 1, 2. Okay. If 0 is 0 truthy or falsy? It's falsy. Okay, so we skip this if statement. Let's go here. If 1, right? Is 1 truthy? Yes, it is. Okay. And then now, what do you want to do? We want to check the opposite of 0 and the opposite of 2, right? What's the opposite of 0? Not 0. It's true. Because 0 is falsy, so let's flip it, so now it's true. True, and what's the opposite of 2? It's false, right? So true and false. That evaluates to being false, and so we don't get to go into the if statement, right? So we keep going. If C is 2. 2 is truthy. Okay, great, so let's go in. If the opposite of 0, that's true, and the opposite of 1, that's false. So true and false, that doesn't count. We don't get to go in here, and so we keep going. And finally reach the end. And this end is kind of like, it's like the default return, right? If we haven't been able to find a true situation, let's just return false. Okay. This is one way to do it. Are there any questions on this? Okay. Yeah. Okay. Cool. So the other way to do this, right, is to divide this up into two if statements is redundant, right? It's a little bit redundant. So let me give you an example. If I say like, well, what's a good example? Let's have a function, right? And this is like give snack to dog, right? This function is going to give a snack to a dog, right? If we want to give a snack, it's going to return true. If we don't want to give a snack, it's going to return false. Okay. So we'll say if like is good boy, right? If the dog is a good boy, right? And right, if is hungry, right? Return true. Otherwise, return false. Okay. So in this scenario, right? If the dog, okay, to get into this return true, right? Do both of these things have to be true? Yes, both of these things have to be true. Let's say is good boy is false. Okay, do we get to go into this if statement ever? No. Let's say they are a good boy, right? But not hungry. Do we get to go in here? No. So we have a situation where both of these conditions have to be true, right? So if you ever encounter a situation where two things, right, or multiple things have to be true, that is the whole purpose of and, right? The and logical operator makes sure that everything on either side of it has to be true. So this can be condensed. This can be condensed into if is good boy and is hungry. Return true. So this block and this block are literally the same thing. There's no difference at all. This is a little bit shorter, right? But nested if statements can be condensed into something like this, right? Because the whole point is I'm never going to return true unless both of these things qualify. How can I make sure both things qualify? You can just use the and. Okay? So knowing this, right? Here we have this nested situation, right? We're doing if something and if something else. Well, why don't we just combine everything, right? Because we're not going to get to here. We're not going to get to return true unless this is true and this is true, right? Both of these things are true. And so you can combine it. You can say if A is truthy and B is falsy and C is falsy. So I'm just like combining everything. So if A is truthy and B is falsy and C is falsy, return true. This is it, right? We took one condition and another condition that's nested and just combined them. Very much like here. Boom, boom. Just put an and in between, right? We have this and we have this. We're just going to move this up here and we're going to put an and in between. Okay? And take this, say and that. And then if so, return true. And if this, return true. Okay? And this is the exact same thing. Oops. And this makes sense like English-wise, right? Like we have three things, A, B, and C. If A is truthy and B is falsy and C is falsy, right? Then we have a situation where exactly one thing is true, right? A is the only thing that's true. So we return true. And this is where only B is truthy and the other ones are falsy. Only C is truthy and the other ones are falsy. Does that make sense? Okay, cool. Awesome. Now yes.
So what I did was I just took like all three conditions and switched it into just one conditional line and just separated the 5 or statements. Would
Excellent.
that be something would it be preferable to just break it out like this, or just do it?
So that's a really good point. That's what I was about to get into. I would say it's probably like at that point it's like a stylistic choice. Um, but let's get into that. Yeah. Um, so something you'll notice here is like we're returning true in a bunch of places, right? Why don't we just combine all of these conditions into one big giant condition? And if any of those conditions are true, return true, and then others return false. So basically, put these all together. What does it mean to put these all together, right? Let's use this dog example. So give snack to dog. Let's say we have something like this function. Actually, I'm gonna take this, and we'll do this. Function give snack to dog, right? And we'll say if is good boy, right? Return true. And if is hungry, return true. Otherwise, return false. Okay. So what is this saying? Let's say the dog is a good boy, right? But they're not hungry. They're just a good boy. Do we return true in this situation? Yes, in this situation we do, because that's the only thing we're checking. If they're a good boy, I don't care whether they're full or not. You get a snack, right? Okay, let's say they're bad. Let's say they're not good, right? And then we go here. But they're hungry, right? They're bad, but they're hungry. Then do they get a snack? Yes, right? Because we've separated out these two conditions where we've kind of moved over from the universe where both of these things have to be true to just one of these things have to be true, right? As long as you qualify for just one of these, you get a snack. Doesn't matter. You can be both of these, right? You can be a good boy and hungry. You'll still get true, right? Now let's say you're neither. You're not a good boy and you're not hungry. Then you don't get anything, right? Okay, so if you ever have a situation like this where two conditions lead to the same result, right? That basically what you're telling the user is that you just have to satisfy one of these things, right? If you're a good boy or if you're hungry, you're gonna get a snack. You don't have to be both. You just have to be one of these. And if you're in a situation where you just have to qualify for one thing, you can use the or statement. You can rewrite to say if is good boy or is hungry. Return true. This right here is the exact same thing as separating out into two if statements, right? Because you have two if statements where if just one of these things qualify, you're going to return true. Well, let's just combine it, right? And say, if either one of these are true, okay, let's say this is false. You're not good, but you are hungry. Right? You have false or true. And what does that give you? True, right? In the or operator, all you're looking for is just one true thing. Doesn't matter if one of these is false. As long as one of them is true, right? We get to go into the if statement and return true. Does that make sense? Okay, so just look at this pattern, right? You have two if statements that both return true, and in that situation, you can basically combine that if statement into one big one. Okay, and just put an or in between. Move this up here and put an or in between. It's the exact same thing. Okay, so that's what we're gonna do here, right? We have all these if statements, and they're all gonna return true. So another way to say this is, if this condition is true, or if this condition is true, or if this condition is true, right? Then we should return true. So we can say, if this condition is true, like this, or if this condition is true, it's the middle one, or if this condition is true, then we return true. I know this is ridiculous looking, right? It's like hieroglyphs. but we basically we just combined it into this one big logical operation, where if just A is a truthy thing, if just A is truthy out of A, B, C, or if just B is truthy and A and C are falsy, or if just C is falsy, right? If any one of these is true, that means we have hit a case where just one is truthy and the others are falsy, right? And so we should return true in that case. Another way to do this, right, is, let's say I had this. What I like to do personally is like take this thing and give it a variable, right? Like what does this mean? What does this mean to you? It means that A is the only thing that's true, right? In plain English, it means only A is true, right? So let's literally say only A is truthy. Only A is truthy. So here, this is going to evaluate to here, and then we put this in here. Only A is truthy, right? If only A is truthy, this is so much easier to read, right? And you can derive this from this. This means this is going to tell you whether A is the only thing that's truthy, yes or no, right? That's how the AND operator works, right? And the same thing here. Only B is truthy equals this. And since this and this are literally the same thing, I can just put this variable here. Okay? Const only C is truthy means this. If only C is truthy. Okay, great. So we have this, right? If only A is truthy, return true. If only B is truthy, return true. If only C is truthy, return true. Okay, great. Now what I'm going to do is I'm going to move this all up here. And we're going to combine it. We'll say if only A is truthy, or only B is truthy, or only C is truthy, return true. This makes a lot more sense, right? If only one, all of these together means if only one thing is truthy. Okay? And to really like, was it like beat a dead horse or something? To really like drive the point home, you can even put this in another variable, right? And you can say only one is truthy. Only one is truthy is the combination of A, B, and C, right? Like this. Like this, okay? We'll say only one is truthy. So now this is insanely easy to understand, right? If only one is truthy, then return true. That's what the problem's asking, right? Well, what is this? This is determined by if either just A is truthy, or just B is truthy, or just C is truthy. Any one of these things qualify, that means only one thing is truthy. And how are these derived? From here. Okay. Any questions?
So
Yes.
out of all these different options, is there like a stylistically best one?
No,
Okay.
there isn't. I would say like probably what's good enough is something like this, right? I think this would fly. And if I were to see this in the code base, I would just put something like a little comment on top saying like only A is truthy, right? Just put a comment up here. Because if you just do this from the get-go, it's like it's overkill and it could like slow down just like the important parts of development. But I would say like this is like, yeah, this is pretty good. I don't love this because it's a little hard to understand, right? There's just so much going on in one line. So I personally like this the most. But yeah. Okay. Yes.
The solution set mentioned converting booleans into numbers.
Converting booleans to numbers?
And it would be, I think it was double bang A plus double bang B plus double bang C equals 1.
Oh, interesting. Okay, that is fascinating. So, yeah, that's actually ooh, I like that. So,
Why does that work?
yeah, man, that's fascinating. Okay, so let me try this. 1 plus 1. Ooh, it doesn't like that. Only 1. Oh, because I defined this too many times. We'll play around with this. Okay, 1 plus 1 is true. 2. What about true? 1 plus true is 2. True plus true is 2. Okay. True plus false is 2. Okay. So there is a trick to this, right? So this solution, right, works because we did this very manually, and we have 3 things. What if we're given a million arguments, right? And we want to check if just one of them is true. We're gonna have to set up a lot of statements, a lot of cases, right? And that's really all terrible. So a trick to this, and this is wow, this is super, I love it. Is the thing that's weird about JavaScript is if you add booleans together, right? What it ends up doing is it converts the boolean to actually a number type implicitly. So true gets converted to a number, which is really weird, okay? And just according to JavaScript rules, true when converted to a number is going to be 1. Right? True is represented by the number 1. And false is represented by the number 0. Okay? True is 1 and false is 0. Okay? So let's say we want a case, right? Where we have A, B, and C, right? And we want just one of these things to be true. Okay, we want just one of these things to be true. So if just one of these things is true, and then we go ahead and add all these things together, right? What should be the sum? What should be the result of adding 3 things, adding 3 booleans, where just one of them is true? 1, right? Because the one true thing is going to give you 1. The other ones are going to be false, and that's going to give you 0. So you get 1 plus 0 plus 0, right? Which is 1. Or 0 plus 1 plus 0. Or 0 plus 0 plus 1, right? In all the cases, you get 1. And so basically, if you add 3 booleans up and you get 1 as a result, that is proof that just one of them is true. Does that make sense so far? Okay. So now the trick is, how do we get all 3 to be booleans, right? Because they don't give us 3 booleans. I mean, here they do, but here they don't. They're giving us 3 like literal numbers. So if I do 0 plus 1 plus 2, we get 3. That makes no sense, right? How do we convert these to booleans? How do we convert anything to be a boolean? With a capital B boolean, right? What's the other way to do that? Double bang. Double bang. Right? So we'll do this, and I'll say only one ABC, and here what I'm going to do is I'm going to console log, right? A plus B plus C. Only one is not defined. Ooh. Okay, we get 3. 0 plus 1 plus 2 is 3. Now instead of doing this, what we're going to do is we're going to say console log, right? This. So what does this do? This takes the 0, converts it to becoming the opposite of its truthy value. So this is false. It's falsy. Opposite of falsy is true. And then the opposite of true is false, right? So this is false, okay? So the first thing is false. And then B is, basically the double bang converts it to its Boolean form, right? So what's double bang of 1? It's true. And is 2 truthy or falsy? It's truthy. It's true. And what happens when we do false plus true? We get 2. And what does 2 mean? 2 means there's more than one thing that's truthy out of the 3. Does that make sense? You definitely don't have to know this. But just to reverse engineer this, like we want to make sure that the three booleans add up to 1 to prove that only one of those things is true. So to have 3 booleans to add up to begin with, we need to type coerce anything that comes in to becoming booleans, their boolean counterpart. And you can use that. You can do that using the capital B boolean, or you can just do double bank. And so I guess the solution would just be return whether the sum of all these things is equal to 1. Is this sum equal to 1, yes or no? True or false? If it is true, that all of these things add up to 1, right? We're going to return true. If they don't all add up to 1, we're going to return false, right? Instead of here, let's do false. True, right? Only one of these things is truthy. Let's say undefined. True. What if they're all false? False. Does that make sense? Definitely don't jump to doing this. This is very interesting and esoteric, but huh?
I said using the 3 equal signs, so we're not allowed to do that.
Oh, you're right. You're right. Oh, interesting. So I guess what you would, I guess what you would do is,
Does not equal something.
yeah, something like that. Good point. Okay.